SwayamPrabha. Digital India. Educated India.
So, good morning friends. In this course on operations and production management, we are talking about unit 3, that is related to location of facilities. In the unit 1, we talk about the introductory aspects of production and operations management, and in unit 2, we talked about the product design issues, service design issues, and selection of manufacturing processes, selection of conversion transformation processes. In unit 3, we are talking about location decisions, and this is our lecture number 3 of this particular unit. In the lecture number 1, we talked about the importance, the strategic importance of the location decisions, and what are the factors to be considered in different types of manufacturing facilities or service facilities. And then in the lecture 1, we also discussed one very important technique, that is decision matrix. With the help of that, we can compare the various alternative locations and decide which particular location is the best for our given application, for our given facility. In the lecture 2, continuing with the techniques, we studied 3 different techniques. One is break even analysis, where we considered the fixed cost and the variable cost or the various alternatives to decide which alternative has the minimum total cost. Then we discussed as a technique number 3, Brown and Gibson method, where we were divided the parameters into 3 categories, that is critical factors, objective factors, and the subjective factors. Then we also did one technique which is called Bridgman's dimensional analysis. So, now at the closing of the lecture 2, I discussed about the another category of decisions which are called single facility decisions, where you have to decide the location of a single facility which is going to meet the requirements of some existing facilities, or which are going to fulfill your requirements through the some existing facility. Some ancillaries are already existing, some other sources of supplies are already existing. You want to set up a factory so that it is best suited for the purpose of minimizing the total transportation cost. Or it can be a warehouse location which you want to set up with respect to existing manufacturing facilities and your market locations, so that the total transportation cost distance is minimum. Also in this category, the example is of blood bank, where we are saying that some existing hospitals are there in a city, and you want to set up a blood bank, a centralized blood bank, which will meet the requirements of these existing hospitals. And then we will say that the number of beds in the hospital, the requirement of blood bank by a hospital is proportionate to the number of beds in the hospital. Then it can be a case of tool room also, where we want to set up the tool room to meet the existing facilities which require the services of tool room. So, that or in a campus like any campus also, we can say where should be the location of ATM. ATM is to be used by the students also, faculty residencies also, and the persons coming from outside, day scholars also. So, it should be so conveniently located that it should be not in one corner of the institute, one corner of the campus. It should be located in such a manner, so that it is convenient to all the users which are already existing on the campus. So, this is how this decision is very important, and coming at several places also, several situations can be there where we have to take such kind of decision. So, in this to take this decision, we are going to study 5 different techniques. One is the load distance technique, second is the transportation model we can apply, third is we will try to see with the help of a mechanical analog also the situation. We will apply the gravity method and the median method. In this lecture, we will also talk about the location of services, location of service facilities also. Let us talk about the first technique in this, that is the load distance technique. So, here we are going to consider load and distance. Suppose this is your geography and these are the existing facilities which are already there 1, 2, 3 and 4, and you want to decide the location of your, you are having two alternate locations, one somewhere here you are having, you are considering, second you are considering here, some two locations you are considering A and B. So, what you will say, suppose that total transportation requirements from location 1 is let us say 500 units, location 2 is 300 units, location 3 is let us say another 300 units, and from this 250 units. And then we will calculate the distance between 1 and B, 1 and A, similarly between 2 and A, 2 and B, 3 and A, 3 and B, between 4 and A and 4 and B. So, multiplied by let us say this distance is D 1 A, this is D 2 A, this is D 3 A and this is D 4 A. Then the total load distance is equal to, total load distance will be, total load distance for location A, for location A will be 500 into D 1 A plus 300 into D 2 A plus 300 into D 3 A and plus 250 into D 4 A, like this. And similarly for location B, it will be 500 into D 1 B plus 300 into D 2 B plus 300 into D 3 B plus 250 into D 4 B. So, like this. So, this is a total load distance. This number, whatever this number will come, we will compare these two numbers, and whichever is minimum, that location we are going to select. So, choose the site with the lowest load distance. So, this is the formula for load and distance, and distance can be calculated. We will talk about that, how to calculate the distance also. One is we can, we are having some method, or we are traveling on these routes frequently. So, we know the distance between location 1 and location A, location 2 and location A, like that, or there are if they are remote sites, or we do not have the, we can having some formulas available by which we can calculate the distances. Or these days Google Map is also available to us to give us the distance between the any two locations, any two cities. We can take the help of Google Maps also for that purpose. So, I have already told load into distance. For location I, what is the distance, and I is the load expressed as weight, number of trips or number of units being shipped. It can be in the form of tons, how much weight you want to shift, or it can be number of trips, how many trips are involved, or it can be number of units to be transported between existing location 1 and the proposed location A. And similarly, D I is the distance between the existing location I and the proposed location A. And this is the formula which we can use. This is nothing but the distance between the two coordinates A and 1. 1 is your existing, and let us say the coordinates of this is x 1, x 2, and the coordinate of this is x y, or x y we can take, and here also we can take x 1 y 1. We can take x 1 y 1 is the coordinates of this, and x y is the coordinate of proposed location. Then the distance 1 A is equal to, very simple, x minus x 1 whole square plus y minus y 1 whole square and under the root. So, this is how we can calculate the distance between the two locations, and this is going to be, we can calculate this distance between the two locations. Okay. So, x y is the coordinate of proposed site, x 1 y 1 is the coordinate of the existing facility. Take one example, simple example. We are having 3 potential sites, 3 alternatives we are having. We are having 3 alternatives locations which we want to evaluate. Location 1, 2 and 3, these are the 3 alternate locations which we want to evaluate to set up my manufacturing facility, which will get the material from 4 different suppliers A, B, C and D. This already we are having 4 suppliers which are existing, and the coordinates of these 4 different suppliers are given in the form of x, y coordinates. And this is the quantity which I am going to purchase from supplier A, this is the quantity which I am going to purchase from supplier B, this is the quantity which I am going to purchase from supplier C, and this is the quantity which I am going to purchase from supplier D. You can call it that this quantity as tons or million tons, or on a per annum so many million ton you are purchasing from these facilities, or it can be some other units also, does not make a difference. So, we are having 3 alternate sites available with me, and there are 4 existing sites which are there, and I have to decide the location. I have to select out of the 3 which one is the best suited based on the load distance technique. So, I will calculate the distance between the site 1 and the supplier A. So, this is the distance between site 1 and the supplier A. We can call it D A 1 also, and so this is calculated as 200 minus 360 whole square plus 200 minus 180 whole square and the under root. So, we will get the distance between facility 1, proposed site 1 and supplier A. Similarly, proposed site 1 and supplier B, supplier C and supplier D. So, we will calculate the distance of supplier A, B, C and D from the site 1. In the same manner, we will calculate the distance of supplier A, B, C and D with respect to site 2, and similarly for site 3 we can calculate the distance of existing suppliers. Now, we can calculate the load distance for site 1. The example is here, we can take site 3. Site 3 is 206.2 into 75. 75 ton is the material which we want to transport, and 105 is the material to be transported from supplier B, 135 is the material to be transported from supplier C, and 60 is the units tons is the material to be supplied from supplier D, and these are the distances we can see, and together we found that 77,555 is the total load distance of site 3, 99,789 is the load distance for site 2, and 1,25,063 is the load distance for site 1. Based on this, we found that this is the minimum load distance. So, we can choose the site 3 out of the 3 alternatives which we have initially thought of. So, we can choose the alternative 3 as a potential site, as a possible site, as the best site among the given 3 locations which are available to us. So, this is a very simple technique, but very useful technique, and we will use this particular method also when we are talking about the plant layout also. We will talk about the load distance there also. So, you have arranged various facilities in the plant, department 1, department 2, department 3, then department 4 and department 5. There is certain type of movement between 1, 2, 1, 3, 1, 4, 1, 5, similarly 2, 3, 2, 4 like this, and then we will find out a particular layout, whether this layout is good or not. We will calculate the total load distance of this particular layout. And then we will also create some other alternative also. We can say that rather than this, if I take like this, I will put somewhere 5 in the middle, and then I will say that this is my 1, this is my 2 and this is 3 and this is 4, and then how this is going to be the total movement of the material in that case. Sorry, let us correct little bit. let us put 4 in the middle, or let us keep this as or we can increase the size of this, because 5 we have shown bit longer here, or maybe let us say this is my 5. If I bring 5 here in between, but what is the load distance in the this proposed alternative, and then we can find out the whether the existing layout is good or the proposed layout is good, or we can generate the different templates and we can compare these different templates with the help of load distance. What is the total load distance movement between the in the total factory for different alternative layouts. So, we will use this load distance as one of the performance measure of different plant layouts also. How to calculate the mileage between the two locations? It can be calculated based on longitudes and latitudes also. A formula is available in the literature, in the books. Your longitude minus latitude, just like x1 and x2, minus this whole square of the two locations A and B, and then the latitude difference in the latitude of the square, and then you have to multiply under root with the 69, because this will give the aerial distance between the two locations, but the road distance can be more than the aerial distance between any two. This is used when the two different countries or states are there, or two the distance is longer. So, but this is slightly this, but the exact relationship is given in this particular formula by this particular formula, but this is too cumbersome. We can so if there is a means in a metropolitan city, we can multiply this factor by 1.3 also, because of you may have to take different routes. For a country level, this factor may be multiplied by 1.4 also. So, we can use this, it is a very simple formula. If we know the longitude and latitude of the locations, two locations, we can calculate the distance between the two locations with the help of this formula, and then we can moderate it depending upon whether we are having a straight route available between them, or if the route is not available between them, then we can accordingly we can give this factor of 1.3, 1.4. 69 is because of the curvature of the earth. So, that is to take care of that particular aspect. Now, let us see the second technique for single facility location, that is the transportation method. So, idea here is to ship the item at the lower cost, and there may be you are having sources which are having some constant supplies, they can supply certain amount, and the destinations have certain fixed requirements, and you cannot have a reverse flow. So, it is a flow is from sources to destination only. So, there is no negative flow, sources to destination only, there is no reverse flow we are considering here. So, negative quantity we are not considering here. So, that is the transportation method, very useful method. So, let us see with the help of one example here also. Let us take a small example to understand the methodology and the formulation of transportation method. Take this example, you are having 3 factories, let us say located at 3 cities, Pune, Ahmedabad and Chennai, and you are having 3 markets also, for example sake A, B and C, which are located at Delhi, Bhopal and Chandigarh, and Pune factory has can supply 150 units or 150 tons, or it can be any unit. Ahmedabad can supply 175, Chennai can supply 275 units. And similarly, the capacity or the requirements of A, the demand of A is 200 and demand of B is 100 units and demand of C is 300. In this example, I have taken this number in such a manner that the total supply is equal to total demand, but there may be a case where the total supply is not equal to total demand. In that case, we have to add either a dummy source or a dummy destination depending upon the requirements. So, that to start with the method, we have to ensure that total supply is equal to total demand by adding a dummy source or by adding a dummy destination. How to solve this? The technique which is there to solve the transportation problem, we call it as a two-step approach. In the step 1, we find the initial feasible solution of the problem using there are several techniques. I will explain you two techniques, that is northwest corner rule and Vogel's approximation method, and then we can find out the optimization also by following the stepping stone method or modified distribution method. This technique you will study more in detail in some other paper of operation research or optimization techniques. Here I will give you a small exposure about this technique. Now we are having a good softwares are also available to solve the problems, either using the Tora software. There is a very good Tora software. There is a POM for Windows, and specialized software like Lindo is also available. We can use the Excel also to solve transportation problems. But today in this particular session, I am going to demonstrate these two techniques of finding the initial feasible solution, and in that also Vogel approximation method gives a very good solution which is as good as the optimal solution also. Many times the initial feasible solution arrived by the Vogel's approximation method is optimal. This is also some popularly called VAM method, Vogel's approximation method, VAM. Vogel's approximation method. So, let us see first the northwest corner rule and then the Vogel's approximation method. Northwest corner rule. To find the initial feasible solution. Out of these cells which are available where we have to transport the material, if we focus on this particular metric, this particular cell is called the northwest, this corner is called northwest corner, this corner is called northwest corner. So, we start from this particular corner. How much I can transport from Pune to Delhi? How much quantity, maximum quantity which I can transport from Pune to Delhi? Pune has a supply of 150, Delhi has a requirement of 200. So, out of these two numbers, the one which is minimum, that much I can transport from Pune to Delhi. I cannot transport more than 150 units because Pune does not have more than that quantity. So, once I have supplied 150 units, the remaining stock available with this is 0, remaining requirement available with Delhi is 50 units. Now, there is no point in moving in this because no more material is available with Pune. So, I will go in this particular direction. Now, next cell which I am going to fill is this one. How much I can transport from Ahmedabad to Delhi? 50 and 175. Out of the two, the minimum is 50. So, I will transport 50 units from Ahmedabad to this. So, nothing is available, and here I am left with 125 units. So, now I am not going in this direction downward, I will go in the rightward direction. So, now I will check how much quantity I can transport from Ahmedabad to Bhopal. Bhopal has a requirement of 100 units, Ahmedabad has a availability of 125 units. So, I can transport only 100 units here. Once the 100 units are transported, nothing is required here, 25 is still available here. So, I will go in this direction, I will fill 25 here. Once I do that, I am left with 275 here and 0 here, and once I have done that, 275 here. So, like this. So, this is my initial feasible solution, but this may not be optimal solution. So, I can do like this. Now, I can calculate the total cost also. What is the total cost of this particular distribution system? I can calculate that also. So, for that, I will see that 150 into 6 plus 50 into 7 plus 100 into 11 plus 25 into 11 plus 275 into 12. So, we will calculate this. This is equal to 900 plus 350 plus 1100 plus 275 plus 3300 and total turns out to be 5925. So, my total transportation cost will be 5925 of transporting the material from various sources to different destinations by following northwest corner rule. And they said this is a feasible solution, this is not an optimal solution. We have to follow certain more steps, we have to check for the optimality, and then we have to do some more transformations, so that I can get the optimal answer. A very simple method, but that will give you the feasible answer. Now, let us see the second method, that is a Vogel's approximation method. That is a Vogel's approximation method. We can write the answer here. Northwest corner rule has given the answer of 5925, and we will compare this result with the Vogel's approximation methods. Vogel's approximation method. This method, the basic premises of this method is to see that if I am not able to use the best cell in a row or in a column, how much penalty I have to pay if I am not transporting the material from the best node available to me. Like from Pune, the best option is to send the material to Delhi, because the cost per unit is minimum for Delhi. The next highest is to Bhopal. The difference between the two, the minimum and the next minimum is 2. I will write here. Similarly, for Ahmedabad, 7 is the minimum, next is the 11, the difference is 4. For Chennai, 4 and 5 difference is 1. Similarly, for Delhi, the best is 4, second best is 6. So, there is a penalty of 2 if I am not using the best alternative, I have to pay a penalty of 2 rupees. For Bhopal, penalty is 3 rupees. For Chandigarh, the penalty is 1 rupee. Okay. Now, out of this, I will select the one which is having the highest penalty. I will try to transport the material which is having the highest penalty 4, and in this row the best is here. So, I will see that how much quantity I can transport from Ahmedabad to Delhi, that is 175 units I must transport, because if I fail to transport this, then I have to pay a price of 11 rupees per unit from Ahmedabad for transporting the material. After doing this, nothing is available here. So, next we are not going to do, and here I am left with 25 units of remaining stock. So, now once this is done, so no more Ahmedabad is under consideration, because no material is available with the Ahmedabad. So, now we are having only 2 sources and 3 destinations, where 2 sources we are having materials and 3 destinations which are having the demand. Now, again calculate the difference 2, again difference calculate 1, and here also now this column we are not considering, in between row we are not considering. So, 4 and 6 2, 5 and 8 3, and 10 and 12 2. So, going by this again, the highest number here is 3. So, I must transfer some material through this node. So, how much quantity I can transfer from Chennai to Bhopal? 100 and 250, the minimum of the two, that is 100 units I can transport from Chennai to Bhopal. Now, once this is done, so this quantity left is 0. So, in the next round I am not going to compare this, because there is no quantity required by the Bhopal, and now I can do the third iteration also. I can do the third iteration. In the third iteration, I will not consider Bhopal, I will consider remaining 2 sources. Now, I am having 2 destinations and 2 sources. So, 6 and 10, the difference is 4, and this is not to be considered. 4 and 12, the difference is 8. Similarly, here 6 and 4, the difference is 2, 10 and 12, difference is 2. So, the highest number which is available with me is 8. So, I will try to transport as much quantity as possible through this node, and that possibility is 25 only. So, this will left with 250. So, once this is done, now all sources are only Chandigarh has a requirement of sorry, here we have not done once we have deleted 100. So, I should have written once we have supplied 100, it should have become 175. Now, we have supplying, so this it should come to 150. So, now 150 units are available here. So, I must supply 150, 150 units are available here 150. So, in this you will find that there is a balance 175 plus 25 is 200, 100 is 100, 150 plus 150 is 300, and we can see row wise also 150, 175 and 25 plus 100 plus 150 is 275. And now calculate the total cost. Now calculate the total cost by using Vogel's approximation method. Let me delete these some numbers to create the space for us to calculate the total cost. So, total cost as we calculated in northwest corner rule, it will be 150 into 10 plus 175 into 7 plus 25 into 4 plus 100 into 5 plus 150 into 12. So, 1500 plus 1225, 175 into 7 plus 100 plus 500 plus 1800, and this total turns out to be rupees 5125 by Vogel's approximation method, and you will find this answer is better than this. As I said, Vogel's approximation method gives better result, but still it is not optimal. We cannot say with surety whether this answer is optimal answer or not. This is but this is much better answer as a initial feasible solution. So, we can apply the transportation method to see that what should be my mode of transportation and how to select the location here. This is the mechanical analog, just to give you a physical idea about the working of gravity method and the median method. So, these are my existing sources R1, R2, R3 are my existing raw material sources, M1, M2, M3 are my existing market locations. So, R1, R2, R3, Rm are my raw material sources and these are my markets. And we are considering that there is a straight line difference, straight line route available. So, we consider Euclidean straight line travel between various existing facilities and the proposed facilities. And we hang the weight equivalent to the material to be transported from Rm to P, from Rm to 2. So, this weight to W2 will be equivalent to the material to be transported from R2 to this facility P. Similarly, this weight Wm plus 2 will be the quantity which you want to transport from your proposed location P to the market M2. So, that is how we can read this particular test, and then we say that if there is no friction at the pulleys and this places and thread is also without stretchable, then wherever this pin will come, wherever this knot will come, that is going to be the location of our proposed site. So, in the absence of friction, the common knot P of M plus N string comes to an equilibrium at the least cost location. So, it will come at the least cost location. So, this frame can also be used to explain the concept to the students. Those faculty, some faculty member may be there, they can have their such kind of a frame fabricated in their institute, so that student can be explained the situation in a much better manner. Now, coming to the gravity method of finding the single facility location. Here in this case we are having existing hospitals, considering 6 hospitals are available, and these are the number of beds at each of these hospitals. Hospital 1 is a 3-bed hospital, 300-bed hospital, hospital 2 is a 500-bed hospital, hospital 3 is a 200-bed hospital, and so on. and then these are the existing these are the location of these existing hospitals 1125 33 36 52 x coordinate and y coordinate of these existing, and total number of beds are 2300. 2300 is the total number of beds to which this particular blood bank is going to serve the various hospitals which are located at different places in the metropolitan city. It is very easy. The optimal location coordinates, let the optimal location has a coordinate x 0 and y 0, and how to determine these coordinates? The formula is very simple. It is a gravity method. So, formula is very simple. The weightage or the score or the number of beds available and the coordinate x 1. So, this is x 1, w 1 x 1, w 2 x 2, w 3 x 3 and so on, divided by sum of all the hospital beds which are there, and by this I will get a answer of 3.48. Sorry, it should have been here. So, I will get a answer of 3.48 as my x coordinate of proposed site, and I will get a coordinate 4.0 in the same manner for my coordinate y. So, 3.48 and 4.0 is the location of the blood bank, and important thing is this is not minimizing the total travel cost. This is, we are considering that cost is proportionate to the distance, okay, or cost is proportionate to the square of the distance. The solution to this problem should be considered around this location, considering other factors like availability of land, cost and cost of the land and other factors also. You may find that let me give you with the help of a map. Suppose let us draw the coordinates here only x, y, z. So, my hospital 1 is at 1 1. So, maybe somewhere here, this is my hospital 1, then 2 5, 2 and 5 may be somewhere here, this is my second hospital, then 3 3 may be somewhere here, this is my second hospital, third hospital, fourth is 3 6, 3 and 6 somewhere here, then this is 5 2 maybe somewhere here, 5 2 can be here, and 7 4 can be somewhere, though we have not or I can shift little bit this 5 2 here, this is my 5 2 and then this is 7 4. Okay, this is location 6. Now, this is the location of my existing hospital, and based on this by following the gravity method, my answer was 3.8 and 4, 3.48 and 4. So, I will get somewhere here. Let us say my proposed location comes out to be here, and here no land is available. This is a let us say forest area or something, and you are not possible to set up the blood bank here, or connectivity is not there or something is there. So, then I will draw the concentric circles and see that where I can get a good location with connectivity and other things. So, I will draw the I may find location here or I may find somewhere here. So, in the vicinity of my optimal solution, I will get the this may be optimal solution, but not feasible, because this is where already something is existing, you cannot do anything. So, you draw the concentric circles and see that close to this, wherever you can find the location of this blood bank, you can go for it. So, this is how we can see on a real life city map also, we can draw this and we can find out the location of my facility. Now, let us see the median method also for the same set of data. It is very easy. So, in the case of median, we arrange let us say to find the value of x coordinate, we arrange these facilities in the ascending order of x. Already the data was like this 1, 2, 3, 3, 5, 7, and then 2300 is my total demand. So, 2300 divided by 2 in the median method, it will be 1500. So, we will see that closer value of 1.30, that is 1600. So, 3 is my x coordinate, and to find the y coordinate, I will arrange these facilities in the ascending order of this. So, 1, 5, 3, 6, 2 and 4. So, that there is the ascending value of coordinates 1, 2, 3, 4, 5, 6 in this manner. So, here it is in a jumbled manner. So, I have arranged them in such a manner, so that they become in the ascending order. So, by doing that, again I am finding 1550. So, this is closer to this. So, I may get a value of 4 for this, sorry, not 1500, 1150. Both are not correct. Let us do it again. So, in the median method, we are going to see applying the median method. So, same question we are taking, same example we are taking, which we have did for the gravity method. Here we are having the list of the hospitals, the number of beds available and the coordinates x and coordinate y. So, in the median method, we will calculate the median value of the so median value for the load is 1150, and we will see that where we are getting the value closer to this. So, this is the value which is closer to this. So, from this I will say that 3 is my value, x value for the proposed location, and this is my table, this is the table to find the y coordinate. In this case, I will arrange the y values of these hospitals in the ascending order. So, in that sense, the sequence will become 1, 5, 3, 6, 2 and 4, and these coordinates are arranged in the ascending order here. Again, I will see the median value, that is 1150, and I will see that search that where 15 closer is coming. So, this 1200 is the closest to the 1150, and the corresponding coordinate is 4. So, x is equal to 3 and y is equal to 4 is the location of the new facility which I am proposing to be set up. Location of the blood bank should be located at 3, 4 coordinate x, coordinate 3 and 4. So, that is the location of my factory or location of my blood bank for this purpose. Now, let us see some small discussions on when you are locating the facilities globally, what are the factors to be considered, and also we will talk about the locating the service facilities. So, why we should go global? What is the advantages we have to see when you are searching, because when you are setting up the global location, administratively it may be more cumbersome, more difficult, but still there should be some advantages of setting up the factory globally in different country. So, one and foremost can be the cost advantage. You are finding that there the cost of manufacturing is less, cost of services is less. So, that is why you are going for that particular location. Many companies, as I said in my previous discussion also, many companies have set up their manufacturing facilities in India because of the cheaper labor available in India. Also in 1990s and 2000, a lot of IT companies came to India to set up their offices and call centers, etc., also for development of the software, R&D purpose also to India, because they were finding that the cost of development, cost of providing these services of call center is least in India, is lowest in the India. That is why they selected that location in India for that particular purpose. There may be scale economies also, that you will get produced in that country and then you serve the surrounding other countries also. The demand of that is high, that you can produce at economy of scales in that particular location, because for that, because of the high demand there. So, that can be another reason for setting up the facility globally, or you want to diversify it and reduce the risk also. If you are having all your facilities and businesses in one country and there may be some catastrophe or some kind of a national disaster or natural disaster can be there, or there may be some political instability is there. So, in that situation, if you are manufacturing facilities are diversified at different locations, you can meet your global demands from that particular facility, you can increase the production rate. But if whole of your business is manufacturing is located in one particular country or state and something very bad happened there, then it will be a very high risk proposition. Or there may be government policy, conducive government policy, like as I am saying, in India at this point of time, government is very enthusiastic in inviting global players to set up their manufacturing facilities in India under the Make in India program and government policy. So, we are not only country level, even our states are also competing with each other. So, to invite and to provide facilities, incentives, etc., for setting up the manufacturing facility, because by setting up the manufacturing facility we are getting 2-3 advantages. One, the employment to our people. If there is a manufacturing activity, lot of people are going to get employed, not only directly, indirectly also many ancillaries will come, many other services will also become, housing growth will also be there, and so on. There may be several indirect benefits also if there is some economic activity in one certain part of the country or in a particular state. So, and secondly, the taxes collection will also increase for that particular state. Along with the employment and other peripheral activities, the tax collection will also increase for the state. And then information and technology exchange, there may be that advantage by setting up the company in some other country, you will get lot of information, lot of ideas about that market, about that developments, about your competitors in that country, you get lot of information, and technology exchange also will be possible by setting up the factories, by setting up the business facilities in different countries globally. So, these are some of the additional factors which we have to consider when we are setting up the facilities in the global context. Now, coming to the service facilities, setting up the service facilities, what are the factors we should consider? In the manufacturing, the focus is on cost, whereas in the services the focus is more on revenue. How much? Because in services you will find that the cost of providing services is very less, profit margins are high, and that is why the focus is on revenue, more the revenue, more the profits. Whereas in case of manufacturing, due to high competition, the selling price is constant, you cannot influence much the selling price. Selling price is decided by the competition, whereas in services the selling price of the service is depending upon the your quality of your services and many other factors. So, and cost is very small. So, the focus is not on cost, rather focus is on revenue. So, we should set up a location of my services at a place where I should get maximum clientele, maximum number of customers, visibility is there, and person should be able to reach, accessibility should be there. So, those are the factors which are going to come very handy when we are talking about the services, because idea is to have as many customers as possible. Cost of providing services, the direct material cost is very small in case of services. Then in the manufacturing we are more concerned about transportation cost, whereas here in this case services we are more concerned in, and depending upon the nature of services, what age group of people you want to have. So, you see the demographic profile of that particular location of the surrounding population, you see the demographic profile of the people surrounding that particular area, and see their income profiling, education profiling, etc. So, that will help you in deciding how much footfall you are going to get at your facility, what is going to be the demand of your services for that particular community, for that particular area. Then also in case of manufacturing, our focus is more on power availability, because a lot of electricity is required, energy is required in manufacturing of this, and here in this case we are more concerned about the population. If the area is densely populated, you will attract more demand. If the population density is less, you will get. That is why you will find that most of the service facilities are located in markets and other places where lot of footfall, lot of people are visiting that particular place. In case of manufacturing, we require skilled persons and also the building cost is very important because the manufacturing facilities are large in size, whereas service facilities are smaller in size. We should look at more at traffic volumes, how much people are expected, the pattern of that, and the customer access, whether the parking place is accessible and adequate parking spaces. Many times we do not visit a particular service facility because we find difficulties in parking our vehicle there. So, that can be one deterrent in that case. So, these are some of the factors which are differentiate the setting of a service location from the manufacturing location. Their service facilities, they can be of two categories. One is fixed service, second is delivered service. If it is a fixed service, all factors which we have discussed earlier are relevant. For delivered service, those factors may not be that important because you are providing the home delivery or you are delivering the services at the customer's doorstep. Okay. So, like bank, theatre, health services, they are more fixed services, and fire, ambulance, police, sanitation facility, these are consumed at the place of the consumer. So, according to that we have to decide. So, here we are considering that total access cost is the objective function of the fixed services and total delivery cost is the objective function of the delivered services, and the cost can be expressed in terms of money, time or distance. So, we are saying that what is the total cost involved or distance involved in visiting the fixed services, and in case of delivered service we see the what is the total delivery cost of that. And for fire, ambulance etc., which are emergency services, idea is not to find the average load, average distance. We should find out the minimize the maximum time. Many times you have read in the newspaper etc., if there is a fire, in how much time the first tanker came from the starting of the fire and the arrival of the first tanker. That is the most important, because first few minutes are very critical. If you are able to contain the fire in first few minutes, that is going to be very important. If you lose that golden period, then it will spread and then it will become difficult to contain and the losses will be more. So, the first few minutes are very critical. Similarly, in case of patients also, for ambulance services also, in heart attack and other, we say the first 30 minutes are the golden period. If we are able to provide the medical support, medical help to the patient, it can save his life or damage will be minimum. But as the time increases, the damage increases and the curing become also difficult. So, in case of emergency services like fire, police, ambulance, it is very important to provide the rapid response. There we should not consider the average distance or minimize the load distance or something like that. Here we are more concerned about minimizing the maximum distance, so that my response time is very fast, and that is why maybe we have to set up more services, more facility at more places in case of service emergency facilities, because they are not driven by the commercial interest, they are more driven by the social factors. Waiting line situation, because of random nature of the timing and frequency of call, talking about the service center, the flow may not be uniform. At certain point of time many customers are coming, at other point of time the service may be ideal also. So, we have to consider from that perspective also when we are designing the because the arrival is of a random nature, arrival of the customer is of random nature. Extremely large and expensive capacity in order to meet the response standard imposed. You have you cannot design the capacity of the service based on the average demand. In case of manufacturing, we set up the capacity of the manufacturing facility based on the average demand, but in case of services we cannot do that. If you do that, then our response time will become very poor and we may lose the customers also. So, we have to design spare or surplus capacity. Maybe I can show with the help of a normal distribution. Suppose your arrival or your demand pattern is normal in nature, and on the average you are getting 100 customers per day. If it is a manufacturing case where your demand is 100 units per day, and because this can be stored, this can be kept in inventory, you may set up your factory at a capacity of 100 units. But if it is a service center, if it is a service unit and the standard deviation of demand is 10, you have to set up your service facility with a capacity of 130. So, that is 3 sigma plus 3 sigma. So, that you can give 99.73% of the response, that 99.73% of the time customer need not to wait for you, but obviously that will increase the cost. You may go for 2 sigma also. In case of 2 sigma, it will be 95% response you will get, and like that. So, you can decide how much cushion, how much buffer you should keep in your capacity, so that you can provide a much better service to your customers. In case of emergency services, you can have mobile locations also. In case of delivered services, you can have mobile locations also. So, that there is a two-way communication between the person who is delivering the services and the base station. So, that he need not to come every time back to the base station and to go to the next customer. In between also he can be communicated and he can give a better response by from in between also he can go to the next required place. Deployment in transit instead of always returning to the home base. So, that can also be considered in case of delivered services. The next part which we are going to take that is also location, which is we call it plant layout. Plant layout is in a way is also a location problem, where we are trying to find out the location of different facilities within the premises which you have selected. It can be just like for academic institution, in where you would like to have the residencies for the faculty, residencies for the staff, academic area, hostels, sports ground, etc. You can plan the location of these facilities on a given plot, on a given site. So, that is also, but it is not called a location problem, it is called a layout problem. So, in the hierarchy, after selecting the location of a plant, we have to go for the location of various departments, various sections. It can be in a manufacturing automobile company, it can be press shop, welding shop, paint shop, engine assembly, machine shop, and final car assembly, etc. So, that can be there. So, we can see that. So, that is also in a way a location problem, but it is called layout problem. The next third level of location problem, we can say in a given department itself, let us say it is a welding shop. In the welding shop, how to locate the various machines, etc., and other things, inspection area, machine and material area and other things, how to locate the various facilities within the shop, within the particular department or welding shop, or maybe in academic institution within the mechanical engineering department, where to locate the various laboratories, research facilities, faculty rooms, classrooms, etc., how to locate that. So, that is another kind of a location decision. And then come the workplace layout, like I am working here on a desk. So, where I should keep my books, where I should keep my pen and other things, where I should keep my files, etc., on my work table. So, that can be there, or similarly in assembly area where you are doing the assembly of some place. So, where to keep the various components, where to keep the finished product, where to keep your tools, etc. So, that is a next level of decision which is involved in this. So, these are all location problems, but they are not called typically a location decision, they are called layout, they are called physical arrangement of the machine, or it can be workplace layout. So, in the next unit we will talk about the plant layout. Plant layout, as you see, if you recollect, we have said that mass production system, and batch production and job shop. Can you tell me for which production system the layout is very important? If you recollect our initial discussion type of production system, for which category the layout is very important? Layout is very important for batch production and job shop production. It is not important here, because in this case we are going to follow a product layout. Machines are arranged according to the requirement of the process requirement of the product. So, it is very important for batch production and the job shop production. Also, we discussed in our when we are talking about the types of production system, line balancing is very important. Line balancing is very important for mass production system. So, for mass production system, the most important thing is line balancing, and line balancing is not required for batch production and job shop, it is very important here. Layout is important for batch production, not important for mass production, whereas line balancing is important for batch mass production, and it has no relevance for batch production and job shop production. So, our next class, next session will be on plant layout and line balancing. Together this is called facility design. This is called facility design. So, we will talk about this in our subsequent classes about the facility design. For batch production and job shop, it is layout. For mass production, it is line balancing. So, with this we close this session. Thank you.